All right, so in this section, we're going to take a look at setting up LODs for our character. And what I want to show is a couple different methods we have to do this inside of Maya in particular, and talk about the process as a whole. So the first thing I want to do is on my character here, I want to assign the texture maps into these blend slots that it has assigned. Now I need to figure out who's assigned to what. If I remember, the first blend here is assigned to our weapon. So I'm going to assign two things into here. I'm going to assign the color, and I'm going to assign in the normal map. So let me go ahead and find that for my fix test here. I still need to come in here and name all these and clean them up, and I'll kind of show you that towards the end here. But for now, let's just get some basic stuff in here. I have not done my due diligences on cleaning this up due to us running into needing to troubleshoot some of these things. And remember, even on this axe here, we may come in here and fix the base of the axe normal as well. So we might still do some finishing touches on this, but that should be good. You know, that gets our axe in here. And the main thing is we can see the specular, we can see the other areas. It could also be good to get in our roughness and metalness and plug that all into, you know, a really nice Maya material. But to kind of keep things rolling here, I'm just going to plug this in using blends. And really, it's most important you just have the normal map, because when you're distorting the geometry with creating these LODs, you're going to be distorting the normals. So it's a good idea to keep these in here and visible. So let's go ahead and get this guy set up for the normals. Just open those up and set that to raw. And then we can go ahead and save this. So that gets our character in here. Looking pretty cool. Back area is kind of interesting. I should probably double check that in Game Engine. Just make sure there weren't any issues there. I vaguely recall there wasn't, so that surprises me if there is. And there's not. Okay, so that's just Maya being Maya. I'm not going to worry about that, but yeah, a little bit suspicious there. Okay, so now that we have these set up, let's talk about what LODs are and how we can go about creating them. As per usual, if you come over here to the polycount forums, there's a whole page on level of detail, also known as LOD, you can read about and different ways to create them. So that's a great place to read up on these. What is an LOD? Let's go ahead and talk about that. Within any 3D application, you have a camera that views the world, and that camera generally is going to have a distance from the object. Now, the thing is, when we're up close to an object, for example, let's use a sphere as our example object, we want to have a lot of polygons to make that look like a sphere. But as we get further away, we can use less polygons and still have that resemble a sphere, and we could use even less polygons and we could have that be represented by a square and still look like a sphere. So how would this work? Well, if I go ahead and take a sphere here, and we put a sphere of 20 right here, and next to that sphere of 20, we go ahead and maybe set this to be a sphere of something like 8. And then make sure it has softened edges. And then we took that and we put that next to a cube that's about the same size in terms of volume. And we go ahead and soften its edges. And we look at these all up close right next to each other. You can see distinctively right now, the sphere is a sphere. The second one has more polygonal shapes, and a cube's a cube. But if we go ahead and back up a distance here, you'll notice at this distance, the sphere and the other sphere are identical. We can't really tell the difference between those two. Even though if I turn on the wireframe, you can still see there's a clear difference in density. And that's the idea of an LOD. Now, you might be wondering about the cube. Well, what if we go even further to here? That's pretty far away, so far that if I go a little bit further, everything clips out, which I could change that. We could set the far clipping plane to be further. You'll see at some point that cube becomes indistinguishable from a sphere. And that's the idea of the LOD. Now, this doesn't make too much sense to us, but to a computer it does. If I come up here to my display, and we go ahead and come to heads up display and set our poly count here, which we're going to want to have on anyway for making LODs, you can see that the computer is currently having to process 760 tries for this sphere. But if we go down to this one here, there's only 112 tries. That is substantially less for the computer to process. And if we go down here, there's only 12. Now, this is kind of twofold because, yes, game engines do culling, meaning that things that aren't off the screen are going to disappear, but maybe you can see why that also matters here, because currently the character's not on the screen, so it can afford to dedicate 760 tries of information to this image. But when I get out to here and this character's now on the screen, and this sphere and that sphere are equivalent, it would be a lot easier for the computer to process 112 of these tries versus 760 in addition to our character's 7,000 tries it has here. Okay, so that's the idea of LODs. Now, there's a couple different ways we can make LODs in terms of working inside of 3D. The number one way is going to be a manual adjustment of this. And a manual adjustment will just be what it is. It is literally manually going in here, and it is reducing this to get a good result. I straight up want to tell you this is the best way to do it in terms of results, in terms of good art. This is not the way we do it for the most part in the industry, and that's because working on one character is a lot easier than working on 100, and 100 is a lot easier than working on 1,000. So manual is going to be one of the best ones. You could also use automated tools. So there's a couple different ways you can automate this. In terms of Maya, we can actually use Maya's LOD tool. So Maya does have an LOD tool. We can also use generic reduction tools. All of these work very well. You can even utilize other applications that aren't exactly designed for this. One of the ones we looked at was already the Decimation Master. Now, the Decimation Master, you do have to be careful with. It's generally not going to give you the best results, but this can often be okay for environmental things. So things that are going to be static, they're not going to move, they're not going to deform. You can also use specialized tools, which also are automated. And these are softwares dedicated to this. Now, I don't have much information here, but some larger studios do make use of LOD softwares. And you can actually Google LOD softwares, and you will find that there are a few out there. So Simplygon's a common one, automatic LODs, and you'll see all sorts of other ones that you could potentially find on here in terms of level of detail. So what we can do is we can explore Maya's level of detail tools. If you come up here to the Edit menu, you can actually find the ability to create LODs down here in the LOD tool. You'll see that you can create an LOD group, you can generate LOD meshes, and you can ungroup an LOD group. Maya actually has the ability to support LODs because LODs can also be used in film, which is something to be aware of. It's not necessary in most cases when you're doing small scale projects, but if you have a large environment, using LODs can be a great way, even if you're doing film rendering. Now, in this case, I'd want to go into generate LOD meshes. And if we click the option box here, you'll see it will open up an LOD mesh menu where we can create these. In here, we can set the number of LODs we want to create. It's currently set to 1. I'll go ahead and reset this tool in case it has any different settings. And we can take a look at different reduction methods. Now, there's a couple rules when you're doing LODs you want to be aware of. The first thing is you want to preserve UV edges as much as possible. This is very important. If you do not preserve UV edges, your textures are going to get messed up. This is one of the reasons why I prefer doing a manual adjustment, is this generally gets screwed up in some way by automated methods. But hey, it's not a bad idea. The next thing is for something like Unity, we generally do 2 LODs. So we'll go ahead and have LOD1 and LOD2. These will be reduced by a certain percentage, and this is going to depend on the type of game that you are working on. So just kind of be mindful of that. The setups we have here at 33.3 and 5% should be okay. It's something you have to play around with. Now down here on the shape, you can see the option to preserve quads and sharpness. Preserving quads, in my opinion, isn't necessary unless you have a character. So be mindful that for a character, it's good to preserve quads because these are going to need to bend and deform. Then down here, we can adjust various things that are going to be important to us, one of which is the UV borders. Like I mentioned, it's good to preserve these 100% if we can. Mesh borders is going to be the end area of meshes. Color borders, I'm not too familiar with that one. Materials are transitions between different materials. Hard edges are going to be important, and crease edges we aren't using here. So hard edges we might want to increase, and as far as the other ones go, we don't necessarily need to calculate those at all if we don't want to. So I don't see a reason to use color borders, material borders, or crease edges in this instance. So basically UV borders, hard edges is what we want, and then mesh borders I'm iffy about. Under the advanced options, you can have some sort of input here. We're not going to bother with that, but we can go ahead and give this a shot. Now, this isn't always going to give us good results, but it might give us good enough results, which is what we care about here. And I'll go ahead and click Generate. And what this will do now is it will go through the process of generating these LODs. Now, what's cool is if you take a look at Maya, it's going to set up an LOD 0, an LOD 1, and an LOD 2. And we can't view these, but if I move my camera far enough, you'll see that the next LOD loads in. So now we're looking at LOD 2, just like we would be looking at for game. And if I move out even further, we'll be looking at LOD 3, right? So as I move my camera, Maya actually can leverage the LOD system. And that's what I mentioned. You might want to actually set this up on a film production because it actually has a purpose. Now, we generally don't want to use an LOD group in Maya because we want to have the ability to edit this ourselves. So under the edit menu, you'll see that there's this ungroup LOD group. You can utilize that to ungroup these and you can view them individually. Now, the main thing is you do want to make sure that you have them correctly identified. I'm going to keep them isolated here real quick. This is what our base LOD looks like. So this is our LOD 0, and we can go ahead and name it accordingly. So I'm going to name this hero underscore LOD 0. I'm going to be using the naming convention Unity does, and LOD 0 is considered our base level of detail. So that's going to be the one we want to have set here. Now, I'm going to go to the next one here, which is identified as LOD 3, and we can take a look at this in terms of its reduction. You'll see that this is at 4,632 tries, whereas our first one here, if I selected it, was at 6,986 tries. And what's really neat here is it looks very minimally different, and that's exactly what we're going for. We want to just make sure there's no weirdness with the visuals and that everything's looking good. The other thing with characters we generally want to look for is the deformation. If there's any areas that look like they're going to be problematic in terms of deformation with how this was reduced. And when it comes to this character, absolutely, those fingers are not going to work. So this is why we might end up doing a manual retopology, but I wanted to show you this as is so you can see the results it gives us. So for a character, we're going to be pretty hard pressed for that because if we come back to our LOD 1 here, you'll see we're completely missing the knuckles. If we go to LOD 4, you'll see that it also did an excellent job maintaining things. And at this point, it's less important that these things be able to deform, but there's certain areas like the axe here, which obviously could have had a lot more reduction, and this area could as well. Okay, so the automated way, not really great. It's not going to work for us here on this character. But what I want to emphasize is that is only because our character needs to deform. For most environments and most props, that automatic LED is going to be great. What we're going to do here is just take a moment to create some manual LODs and get those set up so you can understand, the difference in our goals with these. And then we'll go ahead and test them in Engine. I wanted to show you the automated way first. For those of you who aren't going down the route of characters, if you're going to do props, if you're going to do environments, because that's a one-stop shop. You can basically call it good there and move on. It did an excellent result. That is something I have used heavily when building environments. But for characters, we do need to automate these. So let's go ahead and dive in and take a look at the process of that and what tools we're going to need to use. We'll go ahead and create 2 LODs with some set goals here. All right, so let's get in and get started with this. Be sure to like and subscribe so you can catch the next video in the series when it goes live.